Hey all, I hope you're all doing great. I'm working with a friend to plan a tropical vacation, our first in years. It'll be the first time we traveled further than Costco with our infant daughter, so please wish us luck. Today we're going to be talking about the AWS ECR, or Elastic Container Registry. This is AWS's container image hosting resource, image meaning a bootable file built by Docker or a similar tool. In our next video, we'll actually build an ECR and a Docker image and then push the image to ECR with tags. For you to understand what ECR is and how IAM can help secure it, you'll need to understand the basics of what Docker and containers are. Let's start there. Let's do a quick walk through the history of enterprise compute and how we got to containers. Back in yay olden days, we had big mainframe computers. Okay, it wasn't that long ago, but these were individual operating systems on very big hardware. These are like your laptop or desktop computer are still one operating system on one hardware box. Then we had virtual machines where we had newer versions of these huge mainframe computers and we put lots of VMs on them. Each VM is isolated and we had a hypervisor which helped each VM share the hardware that these VMs need to work and connect to the network. This saves a lot of money and provides great flexibility and operational ease. No more walking to the data center to reboot a stuck host for you. Containers are the next evolution of compute, and they're springing up everywhere. Containers share the kernel with the underlying hardware, the central part of the OS. This is slightly less secure, but it's a lot faster. Booting a container takes only a few seconds. Containers are built to scale out by launching more containers in a cluster rather than scaling up, like launching a bigger VM or buying bigger hardware. Lots of companies you've heard of are starting to use containers due to a host of benefits. Google, Netflix, Uber use them extensively, but also smaller companies are finding the benefits outweigh the cons. Let's talk about how container images are built. Building and running containers are totally separate processes. Let's talk building them. Container images are built from a flat text file that looks like a simple shell script. Docker's build process reads this file from top to bottom and executes the instructions to generate a binary container image that can be run by Docker. Let's look at one of these files at the most common actions. On line 1, there's a from command which tells Docker to start with the local image on our build computer named Ubuntu with a tag, what you see after the colon, of 20.04, which is a version of Ubuntu. If Docker can't find the image locally, like you're running it for the first time, it reaches out to the Docker Hub, a public container registry hosted by the company that makes the Docker tool. These images are very lean and it'll download very quickly. Then on line 4, we have a copy command, which takes a file from our build computer and puts it into the Docker image. Then on line 5, a run command, which uses the native shell in the container and executes a command. In this specific example, we're using chmod to make that copied file executable, but you could do anything the native shell could do. It's very common to load up tools you need for your workloads with yum or apt. And on line 9, the entry point. This is the command or service that is natively run when the container is launched. This is often the single job the host has to run. Most container running tools watch this entry point service, and once it stops, the container is terminated. Its job is done. Let's talk layers. Docker's build and image registry all support the concept of layers. Each of the commands we just went over in the last section is treated as a layer of the container image when it's built. Each layer is only rebuilt if that layer's command has changed or if an upstream command has changed. So for instance, if the only difference since the last build is the command on line 5, line 1 and line 4's commands aren't rerun. Those layers are saved from last time and used again. However, line 5's command has changed, so we have to recompute that layer or rebuild it, and that changes all the layers past it as well. So we have to also compute line 9 and any other commands that we might have after it. This isn't super important until you get into making containers build really efficiently, but you'll see layers during your build and push process, and I want you to know what they are. Let's talk about tagging images. When you build an image with Docker, you have the ability to set a tag, and you should. It makes it way easier to keep track of what is what by assigning a human-readable name to your images. Tags are comprised of a name, like image name, and a version, like v1.0.4. Both can be characters or numbers or both. You set the local tags when you build the image, and then you create a mapping between the local image name and tag to a remote name and tag, even if the remote tag doesn't exist yet. That mapping is created entirely on your computer, and then you push the image to the ECR. If tags and push sound familiar, it's because Docker uses a lot of the standard concepts from Git to manage code. Push requires authentication, and we'll go over how to do that in the next video. One other important note is container tagging on an ECR. There's the concept of tag mutability, which is a true-false flag on the ECR of whether a tag overwrite is supported. Some business units want to override a tag like prod, and some never want that. They'll pin their services to specific image versions and carefully control what services point to them. Let's talk security. We'd be remiss to skip over security and IAM resource policies for this resource. By default, ECRs don't have an IAM resource policy and permit any same account principal to connect to it from any region. If you want to protect your ECR more strongly or share access among several accounts, you're going to need an IAM policy for this resource. You can permit principals to only upload, only read, or anything in between. In this video, we learned all about Docker and how the AWS ECR can host and protect our images. In the next video in this series, we're going to get down and dirty with AWS ECR. We're going to build an ECR, build a Docker image, and test it locally, then tag and push that image to the ECR where other services and humans can get to it. Please like and subscribe and come visit us at iampulse.com. I'm Kyler Middleton at KaiMid on Twitter, and I hope this helps you level up your cloud security skills.